in Drupal. In the same time, it's a very, very important API, but perfectly undocumented one, I would say. So it stays quite a mystery for many. So today we'll try to get to the bottom of it and hopefully understand it. Okay, so let's fasten your seatbelts and start. So quick info about me. I'm Piotr Pakulski. I'm from Łódź, from Poland. So I took a pretty short drive today to meet with you guys. Yeah, I'm a Drupal developer at Box.com, working remotely with a team from Redwood City, California, which is marketing team, and I'm helping them to achieve their goals via Drupal-powered websites. Yeah, I'm a developer for around 12 years now. I started working with Drupal from the late version 7, but just before that I used to be a Symfony developer. So it was a very nice time to join Drupal team because everyone was looking for the background of Symfony when going from 7 to 8. So for me it was just a pretty smooth transition. It was just a matter of learning some Drupalisms, and then because of all the modules that we have under the hood of Drupal 8, it was way easier for me. I published my first website on 1999. When the king of social network was Internet Relay Chat, if everyone remembers. You can find me on, of course, Drupal.org, on LinkedIn, and I also have my YouTube channel called Developer Under the Car, where I am posting all my hobby videos. So it's mainly related to fixing cars, swapping engines, turboing them. So this is my hobby. Feel free to subscribe. As you can see, no one is watching, so yeah. Okay, so I think that's the perfect time to say a big thank you for the whole Polish DrupalCamp team for organizing this event for so many years. I was joining it for many times, but this year finally I have the honor to be a speaker. So thank you very much, and hopefully we'll meet pretty soon next year in the same place. So what's the agenda for today's meeting? We'll start very slow and easy with some basic stuff from PHP, and then we'll climb up and up to see more complexity. So we will start with answering why we probably need some low-level API in Drupal, how it was implemented, how the process on Drupal was looking like, why some namings are what they are, and so on. Then we'll quickly see what was the problem with Drupal 7 not having this API. And finally, probably we'll be ready to see how content entities are built on top of this API. So I will try to point each place where this API is foundation, so you at least will know where this API is present. Then we'll quickly go through some use cases, and probably I will try to answer how you can use this API directly. And hopefully on the very end, there will be a few minutes for some questions. Okay, let's start with something simple. How good do you know PHP? I have a question for the audience. Anyone knows how many variable built-in types PHP currently have? Don't be shy, try some numbers throwing into me.
Around 10.
Okay, 10. Anyone else?
8.
8, okay. 7. All right. Close. But not good enough probably. So currently you have 9 built-in types. So as you can see, some basic stuff like null, bool, integer, float, string, array, object. The two more interesting ones are the callable, which is just a function or a method in a class that can be called via the call user func, and then it becomes to be callable. And resource is indeed a resource, but outside of PHP. Okay, so you were pretty close. There was 8 and 10. We have 9, so congratulations. But it still remains quite, it's remarkable that we have so many good and experienced developers here, and we weren't quite sure how many built-in types we have. So this probably might be the first point why. Probably we need some low-level API in Drupal. And as we all know very good, PHP is a dynamically typed language. If you look in the PHP documentation, you will find this beautiful table representing this particular feature or a bug, I don't know. So this is a loose comparison between some basic stuff like true, false, 1 and 0 represented in different types. As you can see, this table looks very, very random. So this is perfect example why we should probably not use the loose comparison in PHP. Of course, we have the strict comparison. As you can see, this table looks way, way more better, a lot of falses everywhere. But there still remains a question if we can be sure what will be the exact type that we are going to compare by the strict comparison. So we have simple problem, but defined in different ways. Okay, so why we need type data? As we said, we cannot rely on the type of certain data, so we cannot be sure what will be the type coming from external API or external class, module, whatever. We cannot be always sure what the other developers prepared for us, so the strict comparison is not always going to be the right thing to do. So we either use the loose comparison, which is not good in the end of the day. The second point is probably that anyone knows what's the difference between these two integers? I will help you. The first one is a timestamp. So unfortunately in PHP we have no core way to let us know and provide this metadata information that this is indeed a timestamp string or timestamp integer, whatever. So however, in some cases it will be useful to be able to define some kind of abstract type. So these probably are the some simple and basic points why we want to have some low-level API in Drupal to represent our data. This comes straight from PHP. So what was the problem with Drupal 7 back in the day? So of course, because Drupal inherits some problems from PHP, there was no consistent way of defining data types, like letting us know that it's a timestamp or a string. It was not super easy to say field is translatable or not. Possible, but not super easy. Again, the same stuff with access levels, hard to define. Possible, but hard to define. And probably the most famous one, the validation problems, because back the day we had this hook field validate, if you remember. So the validation was very, very, very coupled to form API, which is probably not super good because you want to have these validation constraints attached to the data type you are working with, not to the form, okay? So this was the main point with Drupal 7, and then it was hard to build machine-readable API for data access. Why? Because most of the data in 7 was represented by this giant associative arrays, right? So we weren't sure how to traverse down throughout the data, how to get the additional metadata through the associative arrays. So it was pretty pain and struggle. So if you are interested, you can see the Drupal 7 REST module, how hard it was to build a machine-readable API. Okay, of course the community was aware of these problems with 7. So a lot of years ago they created this Drupal thread to implement the API to unify entity properties and fields. It was more about decoupling the field API systems and taking them into entity properties. Makes sense. And we can call it just a refactor of field API. So at this point there was not such an initiative to create this low-level API to represent data on the very, very low level. So during the process they've decided that probably need something to wrap our data and get rid of this associative arrays, wrap the data, and to be easy to attach any additional info, metadata to it. So first of all, they decided, okay, let's create a metadata low-level API. But then, because the metadata may have different meanings, probably, they decided, let's call it TypedData API. So this is the history and the background why this is the name, not the metadata API. Okay. Of course, there was a very important question, as usual on Drupal.org, why another API? Isn't it an overkill to introduce a low-level API just for the sake of describing entity properties and so on? but the community was able to point bunch of places that will be beneficial from this API, including things like entity property API, blocks and layouts, blocks layouts plus rules with action APIs, tokens, CMA, metadata, semantic mappings, and even template variables. So yes, definitely there was a background to, okay, let's go and build this low-level API. So community prepared this beautiful description of this API. So what the TypedData API will be? It will be a data model that consists of data lists, complex data, and data primitives. Also makes sense. But what was important and was in the back of the heads of community was that it should be very, very easily casted to some primitive representations, like email with type would be mapped to the string primitive without a problem, and so on. So they created this basic table showing the data types on the left column. Some basic one like string, boolean, integer, float, date, duration, URI, and binary. And what's important, in the next columns, they designed how these data types should cast into plain values and further on. So for example, the date will be casted to datetime object coming straight from PHP, and then it will be easily casted to, for example, timestamp as an integer or a string or whatever. The same similar case with duration, that will be casted easily to datetime interval coming straight from PHP and then casted to some string. So this casting of data types was very, very important in the process. Why? Because we have incurred this REST API, so we would like to have a very easy way to consume or provide a data in a different representation than we have in Drupal. So cast the for example, the JSON string into some abstract representation, or abstract representation to a JSON string, and so on and so forth, with different levels of complexity. Okay, so the work was progressing. During the process, community separated this low-level TypedData API into this thread, which is indeed to add a TypedData API for allowing metadata to be associated with data, a lot of data, sorry for that. Yeah, as you can see, it's closed and fixed, which is good. It means it's stable. So finally in 8, we welcomed the the TypedData API. So this is a good image representing what's the difference. So in 7, as you remember, we had to work with these giant associative arrays, and in 8 we have this beautiful abstract representation. As you can see, the node was an entity abstract type, and some values were a value abstract type, and so on and so forth. So yes, we know the history, we know why we probably need this API. So if you would like to know more about this API, where should you go? Probably the first place to visit will be Drupal.org. You will find there the 4 bullet points, but the last one is still not ready, so feel free to contribute, of course. You will find their overview, plugins, definitions, which is perfectly valid. Looking inside of it, you will find some modest descriptions, some basic class names, interfaces names, and so on. But reading this and trying to consume will not give you absolutely any idea why this API is needed, how you can use it, and so on. So it's definitely valid, but it's not going to give you an overview why. You can find there also my favorite diagram, which I'm calling a chicken diagram. I was revisiting this guy for many times, and I'm still not sure if I understand what's on the picture. Definitely the author understands it, but anyway, I'm not going to use it today to try to explain this API for you. Yeah, so if not Drupal.org, what else you can do? You can get this book, Drupal 8 Module Development. In my case, it was 2nd edition. I believe that right now you can buy the 3rd edition, which is Drupal 9, of course, Module Development. I'm not quite sure yet what's the difference between these 2 books. But I would say the number is the main difference, probably. I must say this is a great book, and I believe that everyone should read it in some point of your life. but stay alerted during the process if you are not starting to lose your friends and drinking too much coffee, because it's super hard to consume. Yeah, so what do we have inside about our API? So the author was super kind to provide us 7 from nearly 600 pages book dedicated to this low-level API. What you will find there is a stream of class names, interfaces names, but also very good examples. Absolutely no diagrams or images to explain you what's under the hood. So it is hard to digest this section. Even the author on the very end of this chapter has written that, yes, I know this is a very difficult section to follow. I just want you to know that we have this kind of API in Drupal. Feel free to get bug and try to understand it. So what I have done, I've digested this section and prepared some shortcut for you for today's presentation. Yes, so what is type data? First of all, it wraps values of any kind of complexity, as we might expect. And second, it gives the additional meaning for the data it wraps. So you can imagine that as we were talking about the timestamp, so it's wrapping the timestamp information and adding the additional metadata that this is indeed a timestamp, not a string. Going further with examples, the license plate might be a good example. You have at least 2 pieces of primitive, let's say, information here, which is the license plate number and the country code, right? So then we can wrap them together and add the additional meaning that this is indeed a license plate. So long story short, this is what the API is doing. Going further with examples, nutrition facts sticker. Without the knowledge that this is a sticker, nutrition fact sticker, it would be just a list of random ingredients and so on. But then when you will wrap it together and add this additional metadata that this is a nutrition fact sticker, what's the serving size, what are the calories and so on, then it's starting to make sense. You can treat it like an instance of TypedData API plugin or something like this. And the same structure can be filled up with different values. So we are going to get different instance, different values, different instance. All right, congratulations, because right now you know why, when, and probably how this API works. So it's perfect time to try to look under the hood. So I was trying to find an image that will stay in your memory at least more than 5 minutes after this session. So basically in TypedData we have 2 main pillars, the left one and the right one, and one important player between them, this guy in this hat. So what is what? On the right we have data definitions, which I will call definitions for ease of use, and data type plugins, so plugins and definitions. And this guy between them is a very important guy because he's a manager. He's TypedData manager. So we have plugins, definitions, and manager. And now, to understand what are the moving parts and why, what's their role here, I will use a cooking example because at least for me it's easier to digest. So the plugins. Plugins are simply just some kind of an ingredients that can be more complex ones or less or primitive ones like butter or a glass of milk, or we can treat the eggs like a more complex one because eggs have shell and this beautiful box. So we have a bunch of ingredients, we can imagine, right? And then what the definition is simply a recipe that includes these ingredients, all right? But what's different between this recipe and the real world recipe is that indeed it has ingredients, but it does not contain any values at this point. That is why this guy on the very bottom is grabbing some values for us and is injecting these values into the recipe. And then, as a result, we are getting a beautiful instance of this cake. And this cake is indeed, again, a plugin. But this ingredient, this plugin can be used in even more and more and more complex structure. We can imagine we can have this cake, grab another meat or steak and wrap them together with additional meaning and prepare beautiful dinner. So you can build more and more and more complex structures based on this API. Of course, if you will provide different values for the same recipe, you will get different instance, different values, different instance. Alrighty, so more or less you should be familiar with this API. So let's have a look with some code examples, which always are bored but probably needed here. So we have two pillars, definition and plugin. The plugin is on the very right, which is string, which is a primitive type. And base of it, we are creating a definition. And guess what? We can add some additional metadata to this definition, which is label in our case. Cool, isn't it? And then comes the third part from under the hood, which is the manager. So we are using the TypedData manager, injecting my value inside this definition that we've just created. And as a result, we are going to get an instance of TypedData plugin. In our case, it's data. So what we can do with it? Of course, we can get a value, set a value, which is pretty simple. But what's important, we can get the data definition we created for this particular data, get the data type, which was string, get the label, which was additional metadata, and so on and so forth. So at least at this point, you can see that it's way more machine readable than it used to be with associative arrays, right? Because you can easily traverse down and up throughout the structure you are creating. This is absolutely, very simple structure, but we will quickly see a more complex one. Let's go with another example, which was the license plate. So this is a code representation of our license plate. So we have, again, definitions and plugins. So we have two definitions for the number and for the country code, state code, whatever. And then we are creating the plate definition, which is something different because, as you can see, we are not using primitive plugin to create it. We are using map data definition. What the map data definition really is, if I can highlight it, yes, the map data definition. In very simple words, it's representation, abstract representation for the associative arrays from Drupal 7. So yes, we are creating this definition for the plate, and then we need to let it know that we have some additional properties for it. So we are creating a number here and a state, and as a parameter, we are providing these definitions that we've created previously. So you can see this is a bit more complex structure here. So again, comes the guy in the middle between these two pillars, the manager. And what this manager is doing is simply getting this associative array and injecting into the plate definition that we've just created. And what's important here, which you probably work to each day, every day in Drupal, is that it automatically assigns the correct values to the correct property definitions that you've created in the data type, right? So it's also a way more machine readable way to attach data into the data structures you've created. Why it is so important? Because you would like to expect that you can get some complex, for example, JSON string, and then just using one line of code, inject it into your data type representation. I will show you an example in the very end. Of course, we have instance of another plugin called plate, and this plate you can get a definition for the plate. You can go one level down to get a number, state. Then one level down, you can get the definition from the primitive definitions, and so on and so forth. So you can traverse up and down pretty easily throughout the structure that you've just created. Cool. All right. This is a perfect example why backend developer should never be a UI designer. I prepared this beautiful image especially for you. Thank you very much. So I would like you to focus your attention around this green and red squares. The green squares are plugins and the red squares are definitions. So this is the image representing our license plate. So as you can see, we have two guys, two definitions for the plate number and the state code definition created on primitive plugins. And then these two guys are wrapped together with this giant definition, a red definition, which is plate definition. And what's important, it's built on the map data definition that extends complex data definition base. Super easy names as usual. I would like you to try to remember these names, at least this map and this complex data definition base, because you will finally see that how often it is used in Drupal when you are working with Drupal and content entities, and pretty soon in the next slides. All right, let's go to something even more complex. Finally, we are ready to see how content entities are built on top of our TypedData API. So this is an image representation of the situation. So this first turtle is our TypedData API, and he's stuck on some kind of a rock. Then comes another turtle asking him if he needs any help. And dunk, somehow our entity APIs are on top of our TypedData API, and again comes another API and another API, so these turtles are piling up. So this is probably how this, you might expect it looks like in Drupal. And one day when you will be debugging, it will look like this. But yes, this is how it is, and on the very bottom of this turtles is the TypedData API usually. Okay. Again, using my beautiful designer skills, I prepared this image, which is content entity representation. I would like you to focus your attention on the blue squares, which are the places where the TypedData API is a foundation. Providing a few additional words about the structure is that content entities, as we all know, are built on base fields and configurable fields. The base fields are using base field definition, or if you will change anything in the base field, it's going to be a base field override, which is pretty similar to configurable fields, which might be expected. And configurable fields are field configuration entity, which is something different because it's not a definition. It's playing at least two roles here because it is, besides being a configuration entity, it's also implementing the data definition interface, so it's also a definition. So it's a bit more complex structure for the configurable fields. But yes, as you can see, again, this is all the two pillars, which are plugins and definitions, all right? So you can see how content entities are built using these two pillars. And then we are wrapping these two lists of these fields and wrapping with this giant red definition. And this is entity data definition, which extends complex data definition base, which you probably remember from the previous slide or not. But this is coming straight from our API. So then when fill up with values via the manager, you are going to get entity adapter. You probably heard this name for many times. So right now you probably finally know what's the background of it, which is simply it is a TypedData plugin which defines entity data type. It simply extends straight from TypedData. So you can see at least two places here using extending straight from TypedData, and the red and green pillars used to build it. Going back to our cooking example, this will be very more complex level. As you can see, we can have this beautiful instance of a cake, and on the right, beautiful instance of a steak wrapped together with additional meaning. You can prepare beautiful dinner for your wife. This is what it is in content entities. Okay, this might be good enough, but I've promised you that we will get to the bottom of it. So let's examine what we have inside the base field. Again, I would like to quickly focus on the blue squares here, which are the places where TypedData API is present. Saying a few words about this, simply it's a list of some kind of field types, as you might expect. For example, it can be a string item which extends string item base, but this guy extends map data type plugin. You probably remember this map. So then it's going to be wrapped with this giant definition, red definition, which is basically definition that extends straight from this data definition coming straight from TypedData API. Whoa, okay. Then fill up with values. You can get an instance of field item list, which extends item list data type plugin. Again, at least three places you can see where the classes from content entities are extending our API, and how two pillars, definitions and plugins, are used here. All right, so I believe that this is almost all in terms of content entities and trying to understand how our API is present in Drupal there, but I have a few bonus slides. Again, going back to the cooking example, these are at least low level down, so ingredients are less complex here, and we are getting this instance of a cake. Okay, let's see what plugin types we have built into core. So, bunch of, as you can see. Let's go throughout some of them, like email, flow data, integer data, and item list, which is used in content entities, as you remembered from the previous slide. Language reference, and the most commonly used map, which is simply an associative array. String data, timestamp, and URI. For me, pretty unexpected one was the any. So let's have a look what it is. So any simply is something that may contain any PHP data for which no further metadata is available. Makes sense. So let's try to check if it is used anywhere in core. And yes, it's used somewhere in the datetime item plugin definition. So as you can see, in one of the properties, which is date, they are creating a definition based on this any type. So it's different than any other plugins that we have in core. And I was kind enough to try to look into the history of this API and find a comment that was a source of this any, and probably this was the comment. Okay. So if you would like to start working directly with this API, the probably first and the best place to visit will be this GitHub repository, which is Drupal TypedData by example. What you will find there is simply 4 bullet points. Unfortunately, only these 2 red are ready, so we're quickly going to see how you can work with primitives and maps. Primitives, simply, as you can see in the green big square, we are creating a definition, in this case email, and you can see how easy it is to add a constraint comparing to hook field validate from 7. So you can easily attach the constraint to your data definition, which is cool. And then in the bottom red square, we are using again manager, which is this guy between these 2 pillars, and injecting some values. Then you can go throughout some tests and validations. Let's have a look on the list. The big red square, it's again a map definition because it's the most commonly used, because it's very similar to associative array. So you are setting 2 properties like number and currency code, and inside of them you have another level of complexity, which is data definition based on some primitive types. And then comes the manager, which is creating an instance of another plugin. Cool, so this is the place that I would recommend to go. And finally, the question, where most often you can use this API in the real life. So probably the most often scenario will be when you will be integrating with external data sources, APIs, or data consumers, whatever. So you would like to represent data via abstract in Drupal and be able to easily consume it with 1 line of code, for example. This is a perfect example of this, which is a 5-chart blog, the TypedData API in Drupal 8. I will quickly jump throughout it. So in this case, we will quickly, you can imagine we can have a text field where we will inject a JSON string. This will be the JSON string. As you can see, we have at least 2 levels of complexity here because the results are the 2nd level. And this is the representation, which you probably remember from previous slides. So we have the complex data 1 and complex data 2, which is list data, and some primitive types like status and column and so on. So this will be the representation in our API. So what will be needed? So first of all, we will need definitions and plugins. So because these are these 2 main pillars, so we will need at least 2 definitions because we have 2 levels of complexity here, and 2 custom plugin types. Let's start with the definitions. So this is the complexity level number 1, which is response definition that extends complex data definition base, which you probably remember. Some basic properties like status, command, but the results are a list definition that is created based on our custom demo results type, which we'll quickly soon see how it's built. So we have this first definition, second definition, which is the 2nd level, results definition that also extends the complex data definition base, some basic stuff like title, body, and authorizer properties. So we have first pillar, which is definitions, and quickly going through the 2nd pillar, which are the plugins. First will be the first level of complexity, which is response data, ID, then demo response. 2nd level is demo results, extends map, of course. And this demo results was used here in this yellow highlight. So we have 2 definitions, 2 plugins, we are ready to rock. In the red square, as you can see, we are instantiating the response definition we've just created. Then using the manager, letting the manager know that we have this definition. And what's important is highlighted by the arrow. As you can see, we have JSON decoded string, and what's happening here, we are simply setting value via TypedData Manager, and automatically all the data from the JSON is assigned to the abstract representation, and that's it. Any other line is needed. You are ready to go, just because you've created all the data type representation. You can of course validate, as you can see in the next line. Then you can of course get some values like a command, or get the results for each throughout them, and create nodes or something else. So you can imagine you can go back and forth, changing the abstract to a string, changing string to abstract, but it always, if you will create the proper structure, it always should be one line. Congratulations. Probably you are the one of the very little people in the world who really knows how the API works. Hopefully. So thank you very much. Hopefully this image will stay with you for some time, these two pillars and this guy between them. Any questions? Don't be shy. I can see one person here.
First of all, great lecture.
Thank you.
Congratulations. Finally, my brain started working after some time. So my question is, recently I've been creating base fields for a custom entity of decimal values, and those are represented by a string type. I was wondering why. Maybe I didn't dig into the issue, but maybe you know some history behind it.
I'm not sure if I understand your question, because you said that you have some
Decimal, yeah, those were.
They are represented
some
via string?
Financial values, and yes, they are like.
The question
in
is.
In the type data, it's a string.
It's a string. Okay, so it depends how the data definition was created. If it was created to consume the data, which was integer, but it was created based on string plugin, it's going to be a string, unfortunately. But you can always attach the additional metadata to it, that it's indeed something different than a string, or you should correct this definition if it is a custom definition. I'm not sure about the.
It's actually in car. Maybe because of the separator.
It depends how you.
It can be a comma or.
Okay. Maybe it depends how you consume this data into the data type representation. Maybe it was a wrong way to consume it. I will have to, scan the code a bit.
All right, maybe later.
Yeah, maybe later.
Thank you.
Yeah, I have a question related to the example with working with some sort of API. You had a JSON. So you give us an example when you basically store the data that's coming from the API. So how this behave in case of serializing this type of object to return the response as a JSON?
Yeah, so as the main principles when creating this API was to cast the data back and forth. So it also should be a one-liner. Unfortunately, I do not have any example for you right now, but it's going to work like that. So if you are having this data grabbed from Drupal and it's represented in TypedData custom definition, then one-liner should allow you to serialize it or go to JSON, wherever.
Okay, so the serializer will do the serialization out of the box.
Yeah, this was the idea to have this, besides wrapping the data and adding additional metadata, to cast easily throughout any representation.
Okay, cool. I have another question, which is related to working with fields on the entities. So yeah, there are few different possibilities. You can, for example, get the field value of the node by using the methods get, name of the field. You can also access it via the magic properties, like the field name. The same goes for fetching a values entity. We can use, for example, for first, using the method first, but we can also directly access by value. So what would you recommend?
Depends. I'm not super fan of using magic methods. I would rather go with Yes, with the standard get and set and so on, because first of all, it's way easier to debug. Secondly, it's easier to write unit tests if you are not using magic methods, and probably a bunch of other points that I'm not sure about the TypedData API, but probably it's better to use the traditional getter.
Yeah, but what about values? Because yeah, there's a difference to call the get value method, which will return an array of the values, and then people takes the first value. So using the magic value has the advantages.
Yeah, it has the advantage of faster coding, definitely. I'm not sure if I'm capable of answering this answer, if I'm good enough developer to answer this question, let's say. But the way I would do it is to use the traditional, for example, get value. For my case, it's usually because of the unit tests, because I love to work with this classic method because it's easier to debug and test them. So yeah, probably that would be my answer for your question.
Okay, thank you.
I have a feeling that general rules should be to avoid magic.
I'm not judging. I'm just saying what I would do. It doesn't mean it's always perfect.
I mean, I heard something like that in the past. So try to use, not to use them, yeah? But I'm not sure if this is perfect solution. And sometimes, for example, when we are writing tests, sometimes we skip that rule and use because it's faster to inside test, yeah, but to get the data.
Yeah, on the other hand, there is a possibility to do that. It was introduced by
Yeah.
this API, so why not do it?
I can say I did it once. I used a magic method, and then I realized some other API was just bypassed by using a magic method. So I had to implement an additional validation handler instead of just adding a constraint. So
Yeah.
it's
good example.
better not to.
It's good example again. Yeah. So probably we'll find more examples why we should not than why we should.
As usual, it depends.
Yeah, it depends, of course.
But it still was faster.
Okay, makes sense. Okay, if there is no other questions, thank you very much, and see you next year.